Okay, so here is journal 27, and in this bell work, we're actually going to go back and reuse some ideas that we've used before, specifically on finding values of a triangle. So remember when we were first working with sine, cosine, and tangent, we were given a trig value and we had to draw a triangle based on what we had. So first let me refresh on the SOHCAHTOA. So SOHCAHTOA. So in this case, I have cosine which is 5 over 13, or adjacent over hypotenuse. So I have the adjacent over hypotenuse. So that means that if I were to build this triangle here, let me just build a triangle on the side here, a right triangle, and I put my angle right here, my theta right here. The adjacent side I would know, which is this side, and then the hypotenuse, which is the one that's across from the right angle, is 13. So I don't know what this side is, which is what I'm going to call x. So if I wanted to find sine is opposite over hypotenuse. Well, lucky for me, I have the hypotenuse, and I have the adjacent, but I don't know the opposite. And so I have to figure out the opposite. And to do that, this goes back to the Pythagorean Theorem. So in this case, if I take my 5 here, and I square it and add it with my opposite and square it, I would get my hypotenuse squared. So 5 squared is 25 plus x squared equals 13 squared is 169. And if I subtract the 25 over to the 169, I get about 144. And then if I take the square root of both sides, well, the square root of this would be 12. So it looks like x here is 12. And so now I can figure out what sine is. So like I said, sine is opposite over hypotenuse. So this is going to be opposite, which is 12 over 13. If I want to know what tangent values is, well, tangent is opposite over adjacent, so 12 over 5. And then I would try to reduce if I could, but I can't here. And that's how I find those trig values, is I have to start by taking what I know and then building a triangle and maybe finding the missing side, and then I can find the other trig values. All right, so this skill here is going to come in super handy today when we learn something called the double angle formula. Okay, so these are the last set of formulas that I will teach you. Know that there are many trig identity formulas, but I'm going to teach you just the 5, the reciprocal identity, the quotient identity, the Pythagorean identity, the sum and difference identity, and the double angle formulas or double angle identities. So this is when you are doubling the angle inside the trig, and in this case here, sine and tangent only have one identity, so they make it very easy to work with, whereas cosine has 3 you can choose from. Now keep in mind, you can use any of these 3s and it will give you the identity for cosine double angle. But the one that I will frequently use is this first one, so I'm going to star that one. This one just ends up being usually the easier one to use when you're simplifying, because you don't have to deal with that one where you have to add it to the trig value, which actually ends up being more difficult because it goes into finding common denominators. But it's not too difficult, but let's just say that the first one is usually the more preferable one. And I'll show you once we're doing an example here. All right, so here I have a trig value, cosine 3 over 5, and it says find the trig value of the double angle. And so these are the double angles here. And so we need to know what we're given. We are given cosine 3 over 5, and they tell us it's in the first quadrant. Now this part's really important, okay? So the first thing I'm going to do is draw a coordinate system. And I'm specifically going to draw this in the first quadrant, which is in this region. And the first quadrant is nice because it's all positive. So I know the x and y's that I'm going to be given are positive. So in this case, cosine is 3 over 5. And remember that's, your opposite cosine. Let me write it up here. So cosine is adjacent over hypotenuse. And so if I were to draw an angle in here, and if this was, you know, my angle, I can make basically a triangle from this. So I've made my angle, and I don't know what this angle is, but I know that cosine is 3 over 5, so that means this 3 here is the adjacent side, which is also, so this side's 3, and this side has to be the hypotenuse, which is 5. So that's kind of nice. That means that I know what my x value is because the adjacent side is the x value. I don't know what y is. So that I'm going to have to go find what that is. And then the radius here, or the hypotenuse, is also referred to the radius of a triangle when you're on a coordinate system. So the radius here is 5. And so if I want to find the y value, all I have to do is use Pythagorean. Right? So this formula might look really familiar. So I need to use this formula to get y, because in this case, I need to know what sine 2 theta is. And so to figure that out, let's start by finding our y value. So plugging in what I know that x squared is 3 is going to be squared plus y squared equals r squared, which is 5 squared. So that's going to be 9 plus y squared equals 25. And so I'm going to subtract the 9 over, which makes this other side a 16. If I take the square root of 16, I get a 4. So it looks like my y value here is 4. And so now I have figured out all the sides of this triangle, and now I'm going to find out the double angle of sine. So first off, let me just remind us that the double angle for sine in the formula chart was sine 2 theta equals 2 sine theta cosine theta. So using this formula here, I know what sine is, right? So sine is for this angle opposite over hypotenuse. So the opposite here is 4, and the hypotenuse here is 5. So this is going to be 4 over 5. And then our cosine, well, they actually gave us cosine. It's 3 over 5. So 3 over 5. And so in this case here, all I need to do is simplify. So if I multiply these two fractions, 4 times 3 gives me a 12, and then bottom here is 25. And so if I multiply again, I have to multiply this 2 into the fraction, or I can always write this 2 over 1. And if you multiply, that's 24. Let me erase this part. 24 over 25. And it looks like I can't simplify anymore, so this is my final answer. Looks like the double angle of sine of this specific triangle is 24 over 25. Now, the next one here is cosine 2 theta. Like I said before, the one formula that I'm going to use for this identity is cosine squared theta minus sine squared theta. So this is the identity for double angle of cosine. And so I need to find out what cosine is. So cosine, they actually gave me that value. It was 3 over 5. But in this case, I am squaring the cosine. So I have to square this. And then sine is, well, I grabbed that a moment ago, 4 over 5 squared, because they're both squared. And so now I have to square these fractions. Well, when you square a fraction, you have to make sure you square the top and the bottom. So that's going to be 9 over 25. Because 3 squared is 9, 5 squared is 25. The other one would be 16 squared over 25, and we're subtracting these two fractions. I don't know why I wrote these parentheses. I guess I don't really need the parentheses here. I'm going to erase that. So the nice part, and the reason why I like to use this specific formula, even though I know cosine has like 3 different types, I like to use this one because I always realize that my denominators are the same when I'm working with this formula. So 25 is the denominator here, so I can directly subtract the top. So 9 minus 16 gives me negative 7 over 25. And in this case, I think that's all I can do. So this is my final answer. So it looks like the double angle of cosine is 2 theta. Okay, so in this next one here, I have, again, a trig value, -3 over 5. And so let me just write SOHCAHTOA up here again. So adjacent over hypotenuse, opposite over adjacent. And so if I have sine, that means I have the opposite over the hypotenuse. So if I were to draw this coordinate system, I also have to keep in mind that this coordinate system is in the third quadrant. So it's down here, because that's what it says here, third quadrant. In the third quadrant, that means that it is a negative coordinate system. So x is negative, y's are negative. So when we draw this angle, the angle is always referenced to the x-axis. That's really important that you draw that the angle is between the angle that you draw and the x-axis. So it should never be drawn on this side. And so this angle has a adjacent of, sorry, not adjacent, the opposite of -3. And so that's a y value in the case. And then r here is 5. The radius or the hypotenuse here is 5. And so I don't know what x value is, or what x is. So again, I have to use the Pythagorean theorem. So I have -3 squared plus x squared, because I don't know what x is, equal to 5 squared. So this side's 25, 9's when I get -3 and I square, I get 9. And so if I subtract that to the other side, I get 16, and if I take the square root, I get 4. So it looks like x here is 4. And so again, if I'm looking for the double angle of sine, that's 2 sine theta times cosine theta. And so 2 sine is going to end up being 2 sine is the opposite over hypotenuse, or sorry, I should not be. Okay, so let me pause for a moment. So what I notice is that this 4 here, it's not +4, right? Because we're in the third quadrant, this is also going to be a -4. So this is a -4 we're working with. My sine value here to plug this in would be -3 over 5, because that one was given. But cosine would be -4 over 5, because cosine is adjacent over hypotenuse, so this would be adjacent. This is the hypotenuse. So -4 over 5. And then I would just multiply this through. So I'm going to multiply the fractions together to get +12 over 25. And then when I multiply this 2 with the 12, I get 24 over 25. And then there we go. Can't reduce anymore, so this is my final answer. The last one I have here is cosine double angle. So cosine again was cosine squared minus sine squared. And so cosine here is -4 over 5, but I have to square that. And sine here is -3 over 5 squared. So if I square the top, I'm going to get +16. Square the bottom, that's 25. And if I square the -3, that's +9. Square the bottom is 25. If I have a common denominator here, that means I can subtract. So 16 minus 9 gives me 7. Am I doing that right? I think 16 minus, is 7. And then that'd be over 25. And so this here is my final answer. Okay, so in the next slide here, I'm going to show you for what we would do if we have like a tangent. And so I'll show that one if you guys like to see tangent. All right, so here we have our last slide, and looking at tangent here, we have tangent of -3 over 4, and it's in the fourth quadrant. So before I draw myself like a triangle like I've been doing, I want us to take a look at tangent's identity for double angle. So for double angle tangent, it is 2 tangent theta over 1 minus tangent squared. Do you notice, like, in this formula here, it only uses tangents, right? We're already given what tangent's value is, so we get lucky here. So if I'm already given the trig value that I need and I don't need anything else, I don't have to build a triangle. You might have noticed in the last slide here that I had to build a triangle because, one, I might have been given cosine, but I didn't have the sine that I needed in the formula, or the vice versa. So in this case here, I have 2 tangent. Tangent is just -3/4, so I've just plugged that in. And the bottom here is going to be tangent squared, or -3/4 squared. So all I've done is replace these tangents with what the actual value is that I was given. From here, I'm just going to simplify. Like the top here, I've just multiplied this 2 with the -3 to get -6/4. And then the bottom here, I would square maybe this fraction. So -3 squared gives me a +9. If I square the bottom, I get a 4 squared, which is 16. Maybe reduce this a bit before I keep going. So this would be -3/2 over, let's subtract this first. So this would be 16 minus 9/16. I'm just trying to combine the ones with it. So I get -3/2 divided by -7/16. And so from here, I'm going to multiply by the reciprocal. So I would flip this fraction here, hold the 3/2 still, flip the 16/7. If I multiply straight across, 16 can be reduced to 8 and 1, because 2 goes into 16 8 times, 2 goes into 1 time. And so I can multiply this straight across. So -3 times 8 gives me -24/7. And I think I can't really reduce this anymore, so this is my final answer. And that's it. So we've kind of done each of these trig double identities, or double angle identity. So I hope that helps out with the notes.